Welcome to a new test and teardown video. Look at that big monster of a machine. I think it is it's like very, very heavy. Wow. It's really fantastic. I was so lucky I got this last week at a flea market. But look at that. And this is, that will be nixie tubes, yeah. But I'm a little bit worried about this blue. How's that possible? The filter look like it's blue. So that is a little bit funny, right? So this unit is from the company called Nuclear Chicago. And this machine is called a mediac dose calibrator. Millicurie, microcurie. So what I think this is a Geiger counter with different sensitivity or different counting time or something like this. So what you do here is you select different sensitivity depending on the solution or the radioactive material you're playing around with, right? And then this machine will measure the mixture you have made for the patient, and then you put it down here, and here you go with the calibration factors. So on this we can look up all sorts of things. They even put in some notes. What is that? Correction factors, yada yada yada. What does it say? 2%. So I think it's really accurate. And so the idea is you pick the right solution and the radioactive material, then you have a syringe with this and this amount of solution, and then you can read the value. So this will be a correction factor. You need to multiply the value you're reading, right? It's absolutely amazing. I have no idea what exactly is going on here, but this is all sorts of different mixtures. I saw some notes. Where was see? So here we go with some and this and this and that and whatnot. So as far as I understand, you put the syringe with everything in here, and there is a glass made of the thinnest. Ooh. So some kind of material did drop into this unit. Ooh. Yeah, it's super gross down there. And what if some of this shit is radioactive? So before we play with this, what I want to do is measure if there is any radioactivity in this material here. So let me pick up my Geiger counter. So this is my Geiger counter. Let me see if there's any. Yeah. I think when I hold this in a very special way, I don't know. I think this is more or less the normal background level, isn't it? Let's just take this counter and stick it down this. I think this is safe to say there's nothing bad happening. But it's always good to measure what you're doing here, because you never know if somebody dropped some nasty stuff in here and then just left it, right? Let's look at the back side of this fantastic unit. We got mains is set for 230, so that's fine. We got 2 fuses. They both look perfectly fine. There is a magic connector here. And an interface 0 adjust. What exactly is this doing? And then we can see the Nuclear Chicago Corporation. It even says, what? Oh, I think we should clean this up a little bit, maybe. But anyway, Illinois, Chicago, made in USA, serial number and whatnot. I was told by the guy who gave me this one, thank you very much, by the way, that this one should power up and it's not going to blow the fuses. So let's just power it up and see what happens. I really am ready to power this up. So I think this is an off. Here is mains power applied. Nothing is dangerous. And 30 watts. And we got indication. Let's turn off the light. What is... Ooh! What is that? It's just counting and counting and then, okay. And then it goes... Haha! So it's accumulating something. Right. But it really looks like it's working. But there's nothing in it right now. So let's put in something that is radioactive. Of course, we got a little test thingy. And let's see if this thing is going to change the value. Not at all. Or what? Oh no, look at that. Something different is happening now, right? It's just continuing to count. Oh, what exactly is going on? It's really just counting and counting. 0.6. Really? Is it just me who put in something? Or is it really what is actually happening here? Is it supposed to take this long? Let me try and take this. Okay. Now it goes fast. So the value is really, really high, right? So let's take this up again. Woohoo! And then I think we go to manual, and then we just start, and then we see what happens. I think this is how it's supposed to be done, right? I have absolutely no clue. I think this is just a scalar or a sensitivity thing or whatever it is, right? Don't you just love nixie tubes? That is so fantastic. So it's taking quite a long time to do the measurements. What exactly is this doing? Aha! Oh, look at that. This changes the time that it takes. Or the counting time. Okay, so start. Blah, 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 blah. Very, very, very fast. And then we're done. 6.28. Let's try again and see if it's the same number. Counting, counting, counting. Well, and then we're done. Okay, almost 6. So I think this is the value for almost nothing. Okay, let's put in my little radioactive sample and then let's try again. Did I push? Okay. And here we go. Is it now? It's the same. So what I think is nothing is actually, yeah, it's the same. Well, I will play a little bit with this and then we'll see. So now I've been trying all the different modes and I am not able to measure any kind of difference if I put in my radioactive sample or if I don't. So it's more or less exactly the same. So just to prove if my radioactive sample is actually working. See? Yeah, this thing works. So it's this machine that is not working, so I think we should take it apart and see what is inside. It was super easy to take off the lid. So now we're inside, and look at that. We got some really big glass thingy with a connector at the back, and this goes to some stuff. There is a little secret switch off and on high voltage. Really? So what exactly is going on in here? And what is this? Clearly a glass something. I expect this to be like a Geiger tube or something, actually. We got the big capacitors down here at the bottom, like you can see. Yeah, you can see them down there. 5 plug-in PCBs. Well, all this counting and stuff seems to be working. One of the nixies got a shorted cathode, or maybe it's the driver, I don't know yet. Maybe it's possible to flip down the front panel as well. It looks like there's a screw here for this, so that is probably what I will try next. But so far I am really impressed. So I think this is more or less an exploded view of this machine. I took out all the PCBs and I disconnected the cable for this fantastic sensor thingy. I'm a little bit confused about all those wires. So that is a little bit interesting. Isotope calibration. That is this one. That's that connector, and that connector is connected to the switch that just selects all the different speeds the counters they're running, right? So let's look at the PCBs. Logic. I don't know what kind of logic that is. It's really nice. They say 20 volts. Okay, so this logic runs at 20 volts. Then we got another one that is also called logic B. And here we got a counter. Yeah, some NAND gates and some counters, right? And yeah, that's kind of what that is. And then we got a power supply. Not a lot of stuff of that one. So we got a 20 volt regulated power supplies, minus 12 volts, and probably also a 5 volt because of those counters. They run at, or those 74 series runs at 5 volts. We got some. So yeah, this is the module that is connected to the detector. So there's a detector that goes in here. We got some high voltage capacitors doing some stuff. This is probably where we will see the fault, and probably some op amps. CA3010. I don't know yet what that is. 10 volt trigger, 1 volt adjust, 50 millivolt. Yeah, I can't wait to dig in a little bit deeper on that one as well. Yeah, and this is the isotope calibration board. What this does is, oh, it's dirty, huh? What this does is changes the speed of the counts. So that means the resolution, right? Definitely need to clean this up. And here it says all the different, ooh, look at that. All the different settings gives different speeds. Blah, 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 blah. Run down frequency, whatever. Oops. But it's just resistors And that actually seems to be working, because when I'm dialing around here, it's working. Also, when I'm looking here, I see maybe this is a high voltage rectifier or something like that. This glass tube can also be over voltage or high voltage protection. I don't know yet what that is. Am I missing high voltage, or is it the detection system or whatnot? I need to, of course, dig a little bit deeper and clean up all this stuff as well. I see quite a lot of diodes and capacitors. This means we're doing high voltage multiplication. If you look at, oh, those diodes, look at that, they're in series. And then we've got some capacitors, and up here, some more diodes in series. Ooh, high voltage, nasty stuff. And you can also see this from the dust. It sticks to high voltage. And everything in here is this dirty. So this is the front panel. You can flip this down. And that will be the 3 nixie tubes. And that is, I bet this is 74141s to drive the nixie tubes, and that will be 749s. So let's see if I'm right a little bit later. I am a little bit confused about how to take out this board, because I want to service one of the tubes or one of the 74141s, because we got a 6, or was it 7 and 8 that was sticky. So this, of course, I need to fix. So how do I take up this PCB? We got those 4 screws connect to the front plate around the nixie tubes. But see, if I unscrew those screws, I can't really tilt the PCB because it's going to touch the switch. So it's not really obvious how you take out this board. I would have loved to see a little cutout here around this switch. There's a bulb. There was a bulb, I took it out. And this is, of course, illuminating the selected isotope here, right? But that bulb is, of course, broken, so now I'm trying to figure that out. This wire goes to a series resistor to an unknown voltage. So when I know that, then I can put in a new bulb and figure this out. We got 2 transformators, one here and one over there. So what exactly is that in there? Really good, and some epoxy and all that is super good. So let's look at this magic thingy, whatever that is. We got some dirty stuff down here, so something did leak some nasty stuff down there. And there is only one connector here. I unscrewed this because I thought this was a connector, but that is not the case. So this is the wire to that connector. And there's just like a rubber thingy that holds this glass. I want to take this whole thing out and see a little bit more what is going on here and clean up everything. But I think that this is getting really funny and interesting. I hope so. I hope you're having just as much fun as I am. It's actually turned out to be really easy. I just took out the 4 screws for the PCB, and this actually holds the entire PCB. I thought the connectors for the PCB was actually held down by some of the other mechanical parts down here, but that is not the case. So it was possible just to twist out the PCB and access the nixie tubes. And what do you know? Have you ever seen a nixie tube this dead? Like, it's not transparent in any way anymore. It is just amazing. So, yeah, I definitely need to go and have a look at some new nixie tubes. And this is the other 2. I just cleaned this one super nice. So of course I rubbed away the text. And yeah, I think those ICs, let's get some light. Aren't they? Oops. Hang on a second. So it was good we didn't bet anything, huh? So the nixie drivers, they are indeed 74141s. And the counters, they're of course 7490s. So that's quite easy. So I think all this stuff works quite well here, except for this tube. The 7 and the 8, they were like sticky. So it's either the tube or the driver, but I need to change the tubes anyway, so then I will of course have to check the driver as well. Oh yeah, about the detector. I took it all out and cleaned it up, and there was this rubber gasket here at the bottom. It's really nice and soft, and it was full of some metal parts. All this was completely loose inside here, and I just unscrewed the PCB to have a look at the detector PCB here, and it is really nice. I thought this whole thing was just one big Geiger counter, but I've now assembled the missing loose screws, and there will be of course the high voltage connection, and then we've got two other connections here. One is ground, and the other one is the detector output. It's connected by this BNC that goes to this circuit board. And by the way, look at what it says here on the circuit board: electrometer. So this reveals this thing is not a Geiger counter but an electrometer. It works a little bit like a Geiger counter. So we got vacuum, high voltage, and detection of electrons going through the vacuum, and that is of course counted by this system. As far as I could tell, this particular type of tube here is much more sensitive over a Geiger counter, and that is why we have these very high readings. So that means we get really those high values here are of all those pulses. So look at this, there's like a very hot amplifier here, an 8-pin amplifier. Got some transistors and like a very high resistor. So this is 1000 mega ohms. Is that really right? So of course I'm not touching any of this. It looks like this is the sensitivity. Oh yeah, when this PCB was mounted, then remember this one is the sensitivity screw sticking out, or zero adjust sticking out the back. So this one, you unscrew this to access this zero adjust. Oh, look at this thing to I think this is for humidity, so they don't want moisture to be in here, by the way. Yeah, I think I will put this in later. So now I want to put everything back together here and assemble everything. I still need to clean up a lot more. I cleaned up the glass. Look at that for the nixies. Ooh, now we can look through that again. I'm going to go and find some new nixies, and then I'm going to test if the drivers, the nixie drivers, they work. And what you will see is those are actually 7441s. So those are a little older versions of the very known 7441s. That is just a newer model. But as far as I know, they're doing exactly the same. A BCD, two nixie cathode drivers. So they're exactly the same as 7441s. And then we got the 3 counters. We already know the 3 counters works. So I'm just a little bit curious to know if the first one here is working, or if the sticky bit is in the driver. Other than that, I don't actually understand why we got all those resistors, all those diodes, and all this kind of stuff here, because what is it really doing? What is the point of all this funky stuff right here, right? So looks like this is connected to the BCD side of the counting. And then we got some counting resistors and diodes and stuff. And what is this doing? What is the good for that? And then it's going out of those, doing some other kind of stuff. I actually don't know the reason for that. There is no schematic, there is no information about this unit on the internet. It is just too old, and nobody owned one, had one. There isn't even a single picture of this unit online. Please prove me wrong, and please send a link if you find anything on this machine. Oh yeah, meanwhile I've been searching a little bit around here in the circuit. The high voltage on off is actually, why would you have this, by the way? Why would you need the ability to turn off the high voltage so you can poke around and stuff? You still got 170 volts for the nixies, but as far as I can see, we got AC coming in here, and then this on is up, so this will connect AC to that transformer right here. So that transformer got 2 red wires, and they go to this circuit board. Let me get some, yeah, I actually got light. Let's get some more light then, right? So on this circuit board, the AC high voltage stuff is here. We got some capacitors and all those diodes in series, and then it's somehow connected to this funny thing. Maybe this is a neon bulb high voltage regulator, and then the high voltage goes through this resistor to the connector, and then it goes directly up to that one, this yellow wire here, and then there's a local decoupling capacitor. So as far as I can see, we've got 1600 volts rating on this capacitor, 50 nanofarad. Okay, so that means it is quite a nasty voltage. Maybe it's 1000 volts, maybe it's 1200, I don't know. It's actually just something under 1600. That is all I know. I could just measure this here. So I will boot this up and assemble it again and measure what is going on. So now we are back. I just went to my stash of nixie tubes. So I believe I found some more or less brand new ones. Now you can see through the glass. So this is of course how they need to look, so you can see what you're doing. You can't see anything through these, and they're super dim and bad. So let me just plug in some new ones. Well, new and new. They're like 50 years old anyway. And let's see if it works. I've been cleaning up a little bit here on this PCB and inspecting everything much more carefully and what is going on and not. But look at that one. Look at that sticker. Here in the middle of the picture, so it says inspection and all that stuff. This is an HP sticker. Or this stamp. This is the one you see in all HP equipment. Right? Or somebody else bought exactly the same stamp. Maybe, maybe not. But a lot of things here looks a lot like HP. But it really says made in Chicago and whatnot. So this is not HP, but the fuses are the same. And all this, of course, it's the same components, just the workmanship and the PCB, the text, the everything here is just very much like an HP kind of product. I also see just so many similarities. The way the stuff is marked, the way that, I mean, that is very, very close. So, changing the nixie tubes truly made a difference. Now we got no more sticky 7/8, so that means it was definitely the nixie tube. They're really, really nice and bright. So that is good. Just because I didn't want to blow up my fluke and I wanted to measure the high voltage supply here. So what I did is I put in another 10 mega ohm resistor in series with my meter that is also 10 mega ohm. Went to DC, and chassis needs to be mounted on this thing. And there is actually no chassis connection in the wires. That is actually a little bit weird. And it's also shielded cable, I guess. One of the signal cables. And that one is just connected here. And that is also not chassis. So why did they do it like this? So this unit, well, the chassis around here is, is actually needed. Anyway, so that is funny, huh? So let's crank this up and see the high voltage supply, and it is 250 something, right? And this is via a 10 mega ohm, so it's actually double this, right? So it's 500, and that means this meter should be able to handle the 500. So let's try and skip the resistor and see if this is really true. Isn't this funny? So now I'm directly connected to the high voltage, and now I only see 300. So that means we got quite a lot of resistance in series with the high voltage, because now only half of it is left. So it can't really handle any load. So that is good to know. There isn't any current draw or anything like that. So let's just turn this off. Also, this resistor here in the glass is just hanging all the way up in the air. It reads 1000 mega ohms. So I believe this is a very, very high impedance circuit. We've got some different detection stuff going on here. I am so sad I don't have a schematic of this. So I can't really debug it, and it's just a little bit dangerous to measure around with this. And also the impedance level, I really don't want to waste a whole week figuring this out anyway. See, now it's not measuring anything. It is in auto counting mode, and I disconnected this wire or this cable. So I believe this is the pulses we're counting, and I mean with this one disconnected and it's not counting anything. Let me try and plug it. See? Now it is actually counting. So those pulses, they're definitely coming. Also, here's a little relay. Is it up here? Doing the little clickety click. I think this is for discharging something. Yeah, there's a good and healthy smell. I changed the bulb and a new series resistor for the bulb just to make it glow as nice as I like it to be, because I kind of like it to look like this. This is nice, isn't it? Yeah, now I will assemble the whole thing and just call it a day. I think this was kind of what I could do. I don't actually got the right kind of radiation sources this thing will measure, so this is probably just a zero. Maybe I should just try and poke around with the zero adjustment and see if this counts more or less or whatever it's doing, but I really don't want to touch anything here, really. It is really beautiful after all this clean up and new nixie tubes and all that. Maybe I should have given the indicator LED here a little bit more current. It is quite dim, but anyway, you can still see it is there. So anyway, it's not intended to be really bright, I guess. But it looks really nice. Maybe there was supposed to be light in this one as well. Yeah. I also got this above rating or above range. I need to push this button a little bit. Yeah, it was really a funny machine.